function. It can open up or down. The vertex is the highest or lowest point of a parabola, and that's going to be an xy, the vertex. Axis of symmetry is a vertical line through the vertex that cuts the parabola exactly in half. You might also see it as a line of symmetry. Either thing, they're the same. Minimum, oh, how about that? Minimum or minimum value? That's what you get when you try and do things too fast. This is supposed to be maximum, minimum or maximum.
Can I put maximum or minimum?
I don't care. It's the y value or coordinate of the vertex. It's the y coordinate of the vertex. X-intercepts are the solutions of a quadratic equation where the parabola crosses the x-axis. So this is all stuff we're kind of going to look at in this chapter, even more. All right? So let's just review the basic. We have to work with the parent function. So here is the basic quadratic equation. Here's the parent function. Let's first identify what A, B, and C are in this parent function. What's A? What number is in front of the x squared? 1. What's B? 0. There is no B here, is there? What's C? 0. Okay? This is something you're going to be doing all along often, is identifying A, B, and C. If you had to graph this parent function, you can make a table. Eventually, it'll be such, second nature, you won't even need to make a table. But if x is 0, what's y?
0.
If x is 1, what's y?
1.
If x is 2, what's y?
4.
How many people were going to say 2? If x is negative 1, what's y?
1.
Because negative 1 times negative 1 is 1, right? If x is negative 2,
Negative 4. Whatever.
positive 4. Now, do you have to make a table every time? No. You should memorize these. Parent function, 0, 0, 1, 1, 2, 4. And then it's right flip side of those. So there and there. Okay? And that is the parent function. Now, let's identify some things that are going on here. This line right here is going to be what from our definitions? What's that called? Axis of symmetry. Okay? So that is I'm going to abbreviate it AOS. And it's a vertical line that can be written as an equation, which is what here? X equals 0. Okay? Axis of symmetry, X equals 0. The vertex coordinates are what? 0, 0. The minimum, why does this have a minimum?
Because it's facing up.
Because it opens up. It's the lowest point, the minimum, okay? The minimum, no, it's just the y coordinate. We would say it's y equals 0. The minimum is y equals 0, okay? So that's basically that. With the parent function, just know that it's 1, 1, 2, 4, and then the flip side over the axis of symmetry. What if you got this?
It would just open
Upside down.
All this would do is go down, and let's just look at y. First of all, what is A? Negative 1, and B is 0, and C is 0, correct? So, when A is negative, what's going to happen? When A is negative, the parabola opens down. This is going to be for any quadratic equation that has a negative A, the number in front of the x, when A is negative. If I make a table, which you don't have to do every time, but if I make a table for this, let's see what happens. Obviously, if x is 0, y is 0. Careful. What if x is 1?
Why would it be negative 1?
Correct. You square 1 and you make it negative. What if x is 2? What if x is negative 1? It's still negative 1. Because it's negative 1 times negative 1, which is positive 1, and then this negative out here is going to make it negative. Same with this. Okay? Can you plug it in the calculator? Sure, but isn't there a non-calculator part on the test?
Not on the next one, there's not gonna be.
So really, you can just sketch these. It's over 2, down 4, and then it's opposite over the axis of symmetry. Because the axis of symmetry cuts it exactly in half. Everything is the same here, except this has a what instead of a what. It has a maximum. And the negative, right? It has a maximum here, and that is y equals 0. The y coordinate of the vertex.
What's the minimum?
There's no minimum on this one.
I thought you just said there.
This has a minimum. This has a maximum. Shh. Okay? I don't want to hear any of that bucket dipping in here. Okay, turn it over. Okay, so one thing you're going to have to do is you're going to have to compare this graph to the graph of y equals x squared. So I want you to draw the graph of y equals x squared. You should be pretty good at it now. It's 0, 0, 1, 1, 2, 4. And then it's just reflecting over that axis of symmetry, and it's like this. This is y equals x squared. I bet you can tell me what's going to happen to the parabola when we multiply everything by 1/2. It gets squattier. It shrinks. Because every value is being multiplied by half, so the y values are getting smaller. Okay? So there is no right or left movement, and there's no up or down. Okay? None of that happening. All that's happening, let's make a table. And it's pretty easy. So when you have to make a table, you should maybe do 2x values to the left of the vertex and 2x values to the right. So I just did this, because then it'll give you a really good picture of what the parabola is going to look like. When I plug in -2, -2 times -2 is 4. Cut that in half. You get 2. -1 times -1 is 1. Cut that in half. You get 1/2. 0, 1/2, and 2.
4.5, 8.
So this is going to look like this if you graph it. -2, 2. It's just a little bit squattier. How do you like that? It's a shrink. You call it a shrink. The y values shrink. Does that have a maximum or a minimum?
Minimum.
It has a minimum, which would be what? 0. Okay?
Ooh, the next one's not gonna be 0.
So this has got a little bit of stuff going on. Draw your parent function right away. Draw your parent function. That's y equals x squared. Because you're comparing it. Oh, you know what? I made the graph. I should also put in words what happens to this one. What happens? It's a vertical shrink of 1/2. Okay, this is the same kind of thing. What does the +4 do to my parabola?
It's gonna move it right, up.
If it was in parentheses, you'd go left or right. But this is by outside by itself. It makes it go up 4. Okay? What does the negative do? It's going to flip it because a is negative. What's in front of the x squared is negative, so it's going to flip. What's the 2 going to do? Stretch. It stretches and then it flips. Okay? So it's a stretch of 2. Very easy to get a couple of points here. I'm going to do -2, 0, and 2. You can do it in your head. You really can. -2 times -2 is 4. Times -2 is -8. Plus 4 is what? Then I plug in 0. 0 plus 4 is 4. Plug in 2. 2 squared is 4. Times negative 2 is negative 8. And you're going to get another negative 4, which kind of makes sense. So let's graph that. First of all, with a shift up at 4, I know that my vertex is going to be right here. Correct? It's shifted up 4. So there's my new vertex. There's no left or right. And I already plotted that right there. And then it's negative 2, negative 4. 1, 2, 3, 4. No, I'll just do it in this color. And then over 2, down 4. And then you can just connect them. Here, look. I plugged it in here.
Okay.
2 squared is 4, right?
Oh, that's, okay, never mind. Don't you have the times of
I did.
I thought we were doing negative 2, negative 2.
Let's do 2. Negative 2 times 2 squared plus 4. Do that. Okay? Okay.
Oh.
So this is comparing. You're just drawing both graphs, and we put some words here, we put some words here. Okay, that's one thing you're going to have to do is compare the parent function. Another thing you have to do is work with the axis of symmetry and the vertex to draw your equation. Probably should have you write this here, and I didn't do it. Axis of symmetry, this is the equation you use. X equals negative b over 2a, which is actually part of the quadratic formula.
What is the quadratic?
We'll get to that later. Okay, so we have to graph this. We have to label the vertex and the axis of symmetry. Well, let's just graph it using those, because you're going to have to find the axis of symmetry, which is a vertical line, correct? Okay, so what's A?
Negative 1.
Let's put that here. What's B? And what's C? Okay, if this is my equation to find the axis of symmetry, I'm just going to plug in negative B, which is negative 6. 2 times A is going to be negative 2. My axis of symmetry is going to be X equals 3. So I can sketch that right now, because that has to be part of my drawing. Is this going to help you locate the vertex?
Yeah.
Why?
Because we're looking for X.
The vertex is on the axis of symmetry. Correct. Which means this is the x coordinate of the vertex. Does that make sense? The vertex is on this point. All the x coordinates on this line are 3. So let's use the equation. The vertex is on the axis of symmetry, so plug x in to get y. So we're saying x is 3, so I'm going to plug that into my equation to get y. The vertex is on the axis of symmetry, so plug x into your equation to get y. So that's what I'm doing. Y is equal to 1. So over here, I'm going to say my vertex is 3, 1, x coordinate, y coordinate. The axis of symmetry is x equals 3. I can plot the vertex. It's 3, 1, so over 3, up 1. There's the vertex. I can get one other point from my equation. Does anybody know?
Minimum of X.
Negative 6 and negative
This number is something right here.
0.08.
Does anybody know what that number is?
Yeah, 0.8.
It's the y-intercept.
Yeah.
It's the y-intercept.
Hey, what's that?
Yes, 0.8. If x was 0, y would be negative 8. Okay? So I can actually go down here. 1, 2, 3, 4, 5, 6, 7. It's going to be one more down here.
God, why can't you make better graphs?
Seriously.
Such whiners. If the axis of symmetry cuts my parabola in half, that means I just got to go over here and do the other side. And then I have 3 points, correct?
Yeah, but
And then I can graph it. Wow, that's a terrible parabola. Oh,
Don't
well.
let anybody put you down.
There's the vertex. What is my maximum or my minimum?
One.
What is it? Maximum or minimum?
Maximum y.
The maximum y equals 1. Okay, y equals 1. Okay, this was a lot of writing. We can do this one a lot quicker. We start with the axis of symmetry, which is this equation. So, my A equals 1, my B equals -2, my C equals -1. I like to identify those, just so I don't screw up. Then I'm going to do the axis of symmetry. X equals -b, which is 2, over 2a, which is 2. So x equals 1. My axis of symmetry is 1. So I can draw that line right there. Double check. -b would make my top positive. Okay? Okay, so there's my axis of symmetry. Now my vertex, what do I do to get the vertex?
-1. Plug it in.
Plug 1 into there. Y equals 1 squared minus 2 minus 1. Kind of did that quick. So yeah, what would that equal? -2. So this equals -2, so my vertex is going to be 1, -2. So I can plot that over 1, down 2. Can I get another point from my equation? That's the y-intercept, correct? So I can put that here, and then flip over the axis of symmetry and get the other point. And then I can graph it. Okay? Maximum or minimum? And what is it going to be? Y equals -2. So I want a vertex, a minimum, and the axis of symmetry.
This is max. This is
Okay, almost done. Tell whether the function has a minimum or a maximum value.
maximum in the scope.
Is it going to open like this, or is it going to open like this?
Like
It's going to open down, so it has a what?
max.
Maximum.
That was so easy.
A is negative. Well, we're not done yet. We have to find out what it is.
No, I already took it.
So it opens down. Who broke it? Well, it just went away for a second. That's weird. A is negative. It opens down, so you have to find the y coordinate of the vertex. And how do you do that? Yep, you use the axis of symmetry to find x, and then you plug x in and find y. So use axis of symmetry first. X equals -4 over 2 times -2, which is going to equal 1. I just get that from A, B, and C here. And then you plug it in.
-1. Yeah,
No, it's not. -b would be -4. And then 2 times -2. So you have both negatives equal positive. But I wouldn't doubt that I would make a mistake, so it's good that you check me. Okay, y equals 5, which is my maximum. However you want to write that. We don't even have to do this one. Is it going to open up or down? It's going to open up, so it's going to have a minimum. And it's y equals -19, I'll just tell you.
No, I'd prefer if we could do it.
I doubt it.
I really want to.